Hello, good evening, everyone, and welcome to PerfUp 6. PerfUp today is brought to you by two speakers from Cisco Labs and one speaker from Pearson. But before we get into today's agenda and today's speeches, discussions, let me quickly give an introduction of PerfUp to our new members here that are joining us today. So PerfUp is an initiative to bring together the best minds in the software and quality engineering arena, and that is to share knowledge on new trends and discuss best practices in the field. Each PerfUp event will feature a panel of experts who will speak on their knowledge and experience in the area to inspire individuals to tackle performance engineering. Today, we have Nilanka Vijay Surya from Cisco Labs, Omanta Prasad from Cisco Labs, and Rishki Baki from Pearson Lanka to explore the realms of production performance testing. And that will include monitoring, observability, and production stability within performance engineering. We'll be discovering um, strategies for high-performing, reliable systems in production, environments within the performance engineering landscapes. A quick reminder to everybody here as well, the QR code that you see right now is where you can add all your questions. What I will be doing is dropping a link on the chat so that you can keep your questions coming during the course of the event. If you do not mind, it'll be better if you could direct your questions to the speaker so that it's going to be easy for us to ask the speaker directly itself. And with that, we go to Rifki to discuss best practices in production performance testing. Rifki, over to you.
Thank you, Paba, and good evening to everyone, and thank you for joining this session. So without me taking much time, let's get started. We are going to talk about best practices in production performance testing. Paba, I hope my audio is clear. Got some
Yes,
echo.
all good.
Yeah, okay. So the agenda for today is why we test. Let's talk about why we test, why we performance test in production. Let's go through the production performance testing lifecycle and the stages of the production performance testing lifecycle. And I have a few lessons from few ideas I'm going to share with all the engineers here and the managers, final thoughts and Q&A at the very end. So let's move on to the next slide. So just a quick pro tip. So if you all see this idea bulb in the slide deck, I have mentioned, I have put this idea bulb somewhere. That's a pro tip that I'm sharing with you. So you can make a note of it, and that would be like a summary or an idea that you can use going forward. Okay, next slide. So let's talk about why we test. Now, let's forget about performance testing, production performance testing, accessibility, and so on. But why do we actually test? So there's a question to everyone. If you can use the chat option and tell me in just one word, I just need one word. Why do we test? Let's take a minute, and if you all can put, there are several answers by the way, but I'm looking for one particular answer. Can we have everyone using the chat option to say why we test? Oops, Papa. Okay, any brave volunteers? Let's see who goes first. Why do we test? Anyone? Okay, Hiranta says clarify the process. Okay or not? Okay. I like to first of all appreciate Hiranta for being the very first person. Thank you, Hiranta. Ensure requirements, but I'm looking for one word. So, okay, requirements, system was as expected, bug free. Okay, more. I'm sure I saw the attendance list. There are some very experienced people here. Thank you, Fazlan. Reliability. All correct, by the way. No one is incorrect. Some more. Quality says Hashan. Assurance says Rochelle. Two more. Come on. Somebody? Rismi says performance. And then Nakon says verification. Okay. Papa Sara, you sorry, Papa, you can reveal the answer. So all of you all are correct. I'm not saying none of you all are incorrect. So why we test, one of the biggest reasons why we test is we want confidence in our system. We want to have that confidence that we can deliver or send this system or application to our customers. Our customers can use. You can have that confidence before you send, before you release it to production or when you release it to production. So that confidence is why we test. So if you look at the next image, now these days we have the World Cup qualifiers going on. This is the team that has been selected. Now, depending on how they play during this qualifiers, we'll get the confidence whether our guys will do well in the World Cup or not, right? So this is a test that they are going through right now. So out of many reasons we need confidence. So moving on to the next slide, that's one of the reasons why we do production performance testing is to build confidence. And like I said, any performance testing, you need confidence. So let's see why we performance test in production. So I'll give you some questions, and if the answer is yes to all of these, then your application or your system is a candidate for performance testing in production. So first one is, do you uh, do you have environment mismatches between your production environment and lower staging environment? Does your hardware, network, software differ from production to staging maybe? Next one is the database that you have, the database volume that you have in production and what you have in staging different. Production, you have 1 terabyte of data, and pre-production, you have less than 1 GB. That's a huge difference. Uh, then the next one is, do you have third party integrations that you don't have in staging, but you have it in production? So then again, third party integrations cannot be tested in low environments. The next one is, do you have internal several applications that are integrated, but you can't test that in lower environments? Production is the only environment you can test them. Next one is the most interesting one. Does your business that you're testing have special peak load scenarios, seasonal sales, orders, exams that happen at a peak time, exam results that get published, election results which get published? All of you all are familiar with Black Friday. Like, do you have like Black Friday offers or some Cyber Monday offers or something like that, that all happen and produce that unpredictable, unimaginable load that you cannot test in your low environments. And the next one is, you get a performance issue, but you can't produce that in your low environments. Then what do you do? The Then your option is, you can only reproduce that in the production environment. And one more is, you have monitoring tools that so our next speakers, Nilanka and Omanta, will be talking about monitoring tools. So you have monitoring tools that you have in production, but they are not in lower environments and you're unable to test them. So if you have any monitoring tools. So Papa, if you can go to the next item. So if the answer is yes to all of these or most of these questions, and there are several, I have just summarized some of the key stuff, then your application or your system is a candidate for performance testing in production. So moving on, do do we only test if we have issues if we have those issues that I mentioned? Are there any other reasons why companies do production performance testing? Yes. So I have given some four key items here. So some companies are doing chaos engineering. I'll briefly touch upon that in a little while. So they have adopted this concept called chaos engineering. So if you are doing chaos engineering, you need to do performance testing in production. Testing in production is a concept. So if your company is following that, and something similar to that is shift right testing. I'm sure most of you all would have heard about shift left testing, but there is this concept of shift right testing. So if your company is following that concept, then you do performance testing in production and capacity testing as well. So if you want to test the capacity of your systems and is it ready for the upcoming season, upcoming uh, whatever the scenario that's going to have and upcoming seasonal sales or anything like that, can you do capacity testing? So if you need to do all this, then you need to do performance testing in production. So moving on to the next slide, let me share something interesting with you. So this is a joke or a comedy that I found in internet. So how do you test in a live environment? Something that's live, production is live. You have customers who are coming in. I'm sure some of you all would have tested in lower environments, and you do a small test. And the next thing that you know that you have your fellow engineers, development or any other SRE engineers coming and say, "Hey, did you do a performance testing right now? We are seeing some issues in our system. Our logs are going bad. What is it that you did now?" So I'm sure some of you all have experienced that just doing a performance testing in a lower environment. Now, just imagine trying to do that same or a bigger test in production. What could happen? So something similar to that in this comedy that I read is a doctor goes to a mechanic and he's getting his car repaired. And this is a very proud mechanic and he wants to show off his skills and he's a loudmouth mechanic. He tells to the doctor, "Hey, doctor, what you do in the hospitals as a surgery and what I do in my garage as a mechanic are the same." Doctor asked, "What do you mean the same?" "Well, you do heart surgeries, and I'm repairing your engine. So I also do surgeries. You see, so there's no difference. We are all the same." So doctors just simply asked him one question. "Yes, correct what you're saying. But can you do repair that engine while the car is running?" And there was silence from the mechanic, because the mechanic cannot and will not do engine repairs while the car is running because he knows it's dangerous. But the doctor does the heart surgery while the patient is alive. He doesn't switch off the patient. So the patient is alive and the doctor is able to do a heart surgery or whatever surgery. Something similar is what we are going to do in production. How do you test while the environment is live? Right? How are you going to do that surgery? So let's see how we can get about that. Moving on to the next slide. Okay, that's all theory. Now I told you guys all about theory. You can do that and you can do this, but do companies actually do production performance testing? Yes. So this all started with chaos engineering. Started Netflix is the one who introduced chaos engineering back in 2008. They had a issue related to load, and then they decided that they cannot afford to have any performance issues. If you know, Netflix is streaming video. They cannot have any lag. They need to ensure that their customers are watching their video without any delay and that user experience is maintained. So in 2010, they introduced this concept called chaos engineering, and that's how this caught up with the industry. So then what I read is Amazon is doing chaos engineering. By the way, AWS is supporting some features for chaos engineering if your system is hosted on AWS. Microsoft is doing chaos engineering, and a major US airline, honestly I couldn't find what the name of the airline is, but that research paper said a major US airline. And Pearson, where I come from, we are not doing chaos engineering, but we are doing production performance testing. So I'll share some tips and tricks that how we do it. So if and when you want to implement, you also could do the same. Moving on, how do we do production performance testing? Okay, I'll summarize. What you need to do is just this. You follow the production performance testing life cycle: planning, designing, execution, analysis, and reporting, and finally retrospective and follow up. These 5 stages of the life cycle, if you follow, then you can have a successful production performance test. So let's go to the first one, planning. So in planning, I'll talk to you all about schedule, requirements, and resourcing. Let's go to schedule. So scheduling, okay, when are you going to do production performance testing? The best time to do production performance testing is when your customers are basically sleeping. What do I mean by sleeping? It's when it is least used, where you have to find that time window when your production environment is the least used or which has the quietest time. basically, like I said, when your customers might be sleeping. Okay, then you might ask me, how will Gmail or YouTube find a time where your customers are sleeping, right? That application is used throughout 24/7 and all those. So in that case, you might be able to find a particular region where that set of users in that region are not using it. So you have to work out with historic data. You might have, like we have a capacity planning team to find out what time of the what month of the year and what time of during that month is the least used time. That is your window to do production performance testing. Next, you need to go and talk to your stakeholders, everyone from QA, Dev, SRE, DevOps, business, product, marketing. Everyone needs to agree with you to do production performance testing, and they need to give you that support. So it's a culture change that you need to have. Go inform everyone. If you can have a speaker and go around your office or whatever and announce that you're going to production performance testing, that's best. Let everyone know. Then go into conflicts. Are there any conflicts during that? Now you found a time. Now you need to figure out if there are any conflicts during that time. Are there any planned releases, any maintenance activities that's going on, schedule jobs, and so on. Resolve all those and make sure everyone agrees that nothing is going to happen during that time. Okay, in the production performance testing, are you going to test the whole production environment or a subset of it? Are there any monitoring available in that area that we are going to test? If there is no monitoring, no point doing production performance test, because you are going to test blind. So check all this, and then one of the two key things is define your success criteria. If you do production performance tests, what are the key success criteria that would be concluded as the test is pass? If you don't have that, it's ambiguous. People will come with their own interpretation that this is a pass, this is a fail, and so on. So define what is a success criteria. Define what is a abort criteria. Abort criteria is you are going to test in production. You are going to do a surgery uh, to a patient. If something goes wrong, when are you going to stop? What are the criteria that you are going to stop that surgery or the performance test? So define those criteria and have them all documented. That's the pro tip. Create a performance test plan, document it, put it in a dashboard, show the progress to everyone on the schedule, and finally get all the approvals before you proceed. So that's the schedule. And moving on, requirements. What are the requirements that you are going to test the in production? The non-functional requirements, get those. What are the functionality or the workflow or the subsystems that you are going to test? What is the load you are going to test? Is there a particular load? For example, you want to test 20 TPS, 20 transactions per second, 50 hits per second. What is that? Just get all that, write it all down. What is the workflow that needs to be tested? Talk to your business analyst or product manager. What are the peak load times and patterns? So go back to your capacity planning team or any other team, look at the historic data. So these are all the key KPIs that needs to be measured and tested. Again, document all of these, get a sign off from all stakeholders, because once you get a sign off, there is no question or no disagreement, you move ahead. Remember, you can't test everything in testing. You can't do exhaustive testing, and in performance testing, and especially production performance testing, you can't test everything. So choose what is the most important and critical workflows that needs to be tested. Moving on is it's the people. So you have the schedule, you have the requirements. So what about resources and people? Paba, next slide. Yeah, so choose the best team, the team with the best technical skill, the team members with best technical skills with the load testing tools. They should have a good business domain knowledge. They're able to handle pressure situations. They are good at communication, because you need to communicate for a peer engineer, a senior, maybe even the vice president of your company. You need to be able to communicate with them. They should have good leadership, negotiation skills, and a basically good team player. So from this, you can understand this is not something for freshers. This is not a place for freshers to be included, because you need to have experience and these skill sets to do this type of testing. And with people, it's cross functional team. This is not about the engineer who is going to test. This is not about one set of team that this is going to test. Like I told you before, dev, QE, DevOps, operation, product, marketing, everyone needs to be involved in this. It's a cross team effort. What's the pro tip? I told you this is not something for freshers, but this is a good place to tag a junior resource or an intern with an experienced team member. They are going to learn immensely while they see what's going on. And this is an ideal, great on the job training for any fresher or intern to be while they see their experienced colleagues do this test. Moving on, let's go into tool selection. Okay, what's the best tool to use? Is it load runner, JMeter? What is it? Well, the answer is it depends on what you want to do. And I have given some criteria here. How easy it is to use. Okay, how can you do a quick recording? How is easy it is to reuse? Can you go back and modify your scripts easily? Okay, how close to real world scenario or the browser it is, how accurate it is. Okay, can it run at scale? Can you ramp up to a very big load? Okay, does it support multi-region cloud capability? Does it support logging, reporting capability? You need to have a good report at the end of the day to give a good analysis. And does a vendor support training and any other support that with regards to the product? So these are some criteria that you need to consider when you're selecting the tool. Okay, now the planning is done. We go into the next stage of the performance production performance testing lifecycle design. So let's go to the next slide. Test data creation. Okay, take a moment. We are going to create test data in production, and you have created test data in production. Okay, wow, good, great. Your manager is happy, everyone is happy. Next day, the customer sees this. Papa, can you show the first image? Okay, Cisco is with restaurants, so I thought I'll do this. What if your customer logs in and goes to order online something in a restaurant, and he or she sees this, a menu? For desserts, you have lions, pandas, fox, and for lunch you can have zebra. I am not sure what they will think, whether lion is going to have you for dessert or you going to have a lion for dessert. Okay, why did this happen? Because some engineer went and created test data and uploaded all these images in, and he changed the name the restaurant to product test 123 restaurant menu, and now the customer logs in and sees all this. Do you want this to happen when you create your test data? Let's go to the second example. Okay, a child logs into a second grade child logs in and sees this card, and it says he's from class 1900. He's 99 years old, second grade. His teacher's name is Perf Teacher 2023, and it says I love interest 123. Now, what happened here? The child and the parent will be wondering what happened to my children's data. Where did it all go? What went wrong? Why? Someone created data in this child's classroom when they are not supposed to do, and this is what the child sees. I'll come back to that highlighted September 8, 2999 in a little while. Let's go into the next slide. Creating test data is very vital even before you start production performance testing. So you need to create realistic data. Okay, what I meant by realistic data, Papa, if you don't mind just going back to the previous slide. I said realistic data. See September 8, 2099. So this is an example where one engineer who needs to create production test data for a date went and created the most highest possible date that's possible in that system, so that will never expire. Okay, so 2999 is not a realistic data. So if you want to take a report for the within one this year, and this there's a functionality that would capture the next 2 years, this particular data set will never get captured. We'll go to the next slide. So realistic data is something that you need to create. Make sure that you have realistic data. Isolate your data only for performance testing. Talk to the experts, domain experts and everyone to find out how only your performance test will have a separate data set, so that the examples like I told you in the previous slide do not happen. Have a naming convention and inform everyone, if you see any test data with this naming convention, this is a test data used for production performance testing. Remember, there are a lot of data compliance laws and laws that are there in especially in the international market, like PII, personal identity information, and other laws that are there. So be aware of those laws when you create your data. Automate your test data creation as much as possible. This will help you save time and effort. Once you create the data, validate it, because you don't know if what the automation script did is correct or not. Uh, do run and also remember, whatever data that you create is the same data that needs your smoke test and other teams also should use. So performance team has a different set of data and the other teams have a different set of data. That's going to cause issues. Again, get approvals. Quick pro tip, think about it. Can you delete what you create? I'll get back to that later. Let's move on to the next slide. Okay, time to start scripting. Finalize the workflow. You have the approval. Start from scratch. My best advice to you is, when you are testing in production, don't transfer your scripts from another environment to here. One of the reasons why we test in production is because production environment is different. There are lots of risk in trying to move one script from one area to here and just changing the URL. Don't do that. As much as possible, start from scratch. Follow the best practices that you know in any other environment in scripting. It's the same in production. Make sure that you get your reviews done, and make sure that your what you script can be run multiple times. And pro tip, remember to review your scripts with your developers and the product team. Let's go into the next slide. Now it's the scenario. Now you have the scripts. Now you need to plan your scenario and how you are going to do this. How long do you need? What is the ideal time to test in production? Well, it depends on your project. It's on a case by case basis. Depends on your platform and product. Okay, that you need to determine. Don't ramp up very fast. Don't stress your environment. Remember, it's a load test. Figure out the pacing and timing. What is the pacing that you need to reach? Maybe it's like 10 TPS, 20 TPS, or 1x, 2x. Those are terms that we use to reach a particular load. Okay, figure out that time. So in this example that you can see, I have put an example of a telecommunication company. So they have application which they handle mobile calls, broadband data, streaming video. There is another system where you can purchase devices, and then there's all this is connected to payments and billing. Now, if you are going to test all of this in production at once, how are you going to test this multi-business scenario? Are you going to put all these different scripts in one scenario? Or are you going to put them in different machines? How is the timing between them? Are you going to have some noise or background load in while you do this? These are some of the things you need to figure out. So the best pro tip that I can give for this is, do a trial run. Nothing like a trial run before you do the actual performance test. Okay, you figure out what's best for you when you do the trial run. Let's go what a trial run is. Trial run is a small amount of users that do not impact the ongoing traffic. You can do it anytime you want. You put a small amount of users and see if your script is working. Do you see any issues? Can you ramp up, ramp down? So without any problems, whether you can do this. That's a trial run. And remember, you need approvals. And when you do trial run, also monitor all channels and communication. Let's go into the execution phase, the third phase of the life cycle. Let's go into the pre-test activities. What do you do before you, now you're ready, the scripts are ready, everything is ready. Now what do? You got your approvals. Before you start the test, check that those approvals are valid still. Run a automated, preferably automated smoke test and see if there are no issues. Okay, no issues. uh, Check for any maintenance jobs. Is the system health of all the systems in production are good? Any ongoing issues or any customer escalations or anything like that? No issues, then good. Then get everyone into a call or a chat or a meeting. If you can physically get them into a meeting room like this, is sometimes we call this like a war room. Get everyone there, mark all the attendance, because if you don't have the important people, you are running a risk of doing the test without an important person in that call. Okay, now you're ready with all the testing activities. Let's start the execution. Okay, what do you do with execution? First thing, not running the scripts, communicate. Communicate every single thing that you are going to do. Every single thing. I'll quickly tell my best example is how you would see pilots flying a modern day jet aircraft. You would see the pilot telling his co-pilot, I'm going to do this, I'm going to turn here, I'm going to go into this level. Then the other pilot says, check. I note it down. They communicate with the air traffic control. They say, yes, we are going to do this, we are going to do that. They repeat what each other said. That's how you need to be communicating. Basically what I'm saying is make sure that everyone understands what you say and they note it down. Communicate everything, record everything that's going on. If you can record the meeting that's in progress, that's good. So let's go to the next one. Have If you can have a dashboard, that will be good, so then everyone can see what's going on. Remember, the next option is start slow, don't rush. This is not a testing environment, this is production. Okay, next one. What do your users actually see? Are they when now the execution is happening, what do your users actually experience? See, make sure that you make a note of that as well. Next one. Okay, now everything is going correctly. You notice a issue. What are you going to do? Are you ready to press that emergency stop button? Okay. If you see a issue, engage the relevant teams immediately. See what the issue is. Can the test be stopped immediately if needed? Determine that. Make that decision. If it can be troubleshoot, and if that issue can be resolved immediately, then no need to do anything drastic. Okay, but be cautious. Anytime anything can happen, you need to be ready to stop the test. Okay, now the next one is when you are checking system, make sure that you check your system health, KPIs regularly. Are the response times happening correct as per expected? Are you achieving your goals? Are you deviating? Note down everything. You would need that later uh, in your reports, basically. Okay, and last one, but this is just a few out of the many things I tell you. Keep an eye on your approved time window. Remember, I told you you have a small window to test. Make sure that your test is within that approved time window. Pro tip for this is don't rely only on your load test to tell you if there's an issue or not. Okay, you can have some automation scripts running in some other machines to tell you if your automation scripts are failing. Okay, log in actually to the system through a browser to see whether what you might see a failure in your performance testing tool that shows a failure. You can actually log in and see whether that failure is happening or not. So that's something that you can do. Let's move on. Okay, now the testing is done. Everything is okay. Test is stopped. Run a smoke test again to see that all systems are normal. Again, check with operations. Is everything okay? There are no issues. There are no customer issues. There are no customer calls that are coming in. If there are issues, stay back and help them support to resolve the issue. And finally, announce the closure in the call or chat and finish it. What's the press pro tip that I have? Take a break. Just like you take a drinks break in a cricket match, take a break because there is some more to come. Let's go to the next one. Analysis and reporting. One of the best and one of the most important things is what you are going to report. Like one famous news channel say, you report, they decide. Don't do like that, but you need to report. Okay, first thing, do a quick summary report. Just like the news channels, when something happens, do a quick summary report. This is what is the test we did. We observed A, B, C, these issues. We'll get back to you with a detailed report. And then within the next business day, get back to the detailed report with all the facts and figures. What is the load you put? What are the issues you saw? And what are the bugs you have raised? Okay. And put all that and publish the report. If you need to have a meeting, call all the relevant stakeholders, have a meeting and make sure that they understand the meeting. Sorry, understand the results. And make sure, sometimes remember, you need to have these results baseline for future reference as well. So whatever you report is really important. What's the best pro tip I have for you all is, you might see a issue in your scripts or in your reporting tool, but it might not be a real issue, or it might not be an issue with certain applications. I told you, like in my previous example, billing. You might see an issue with the billing module, but you might say, ah, great, I know this billing is causing an issue, this is having high response time. Billing team, this is your bug. Don't be in a hurry to report this against the billing team. For example, it might not be the billing team, it might be some other team that is causing this issue. So consult your relevant stakeholders, talk to them, make sure that they understand and you understand what the issue is before you publish the result, because when you publish it, it goes to a wider audience. Lots of people are going to read this. You need to make sure that what you report is correct. Let's move on. The last stage of the performance testing lifecycle, follow-ups and retrospective. What happened to the bugs that you reported? Have they fixed it? Do you need to do another test run? Any changes from the performance test or test that you did? Does your test approach have to change? Do your scripts have to change? What are the things? So that's what I meant as retrospective. So you need to follow up and see what are the changes that you need to do. Remember, any changes that's required because of what you found in a production performance test, if it's a bug fix, those fixes have to go into lower environments as well. If it's a change in your script that needs to happen, sometimes you need to go back and apply that in your lower environment as well. And the next follow up is, what's next? Do you have another test that's coming up? When is it going to come? What are the changes that needs to be done? So this is something that you need to do in your retrospective and follow-ups. Next one. Okay, side effects. We did the surgery. After the surgery, what are the side effects? We did the production performance testing. What are the side effects of a production performance testing? Lots and lots of data junk in a database. Like this pile of cars in a junkyard, there'll be huge loads of data that you have created now lying in your production database. What are you going to do about it? Remember, I told you, when you create data, see whether you can clean it. Now is the time to think about to clean up that database. Okay, your monitoring and login system would have that extra overhead and extra data that they need to figure out, that their systems will have to look into this as well. So there is a concept called metric tagging. So if you do that, your monitoring and login systems and your uh, logging teams would know to exclude this data. So talk to them and figure out that metric tagging. Then your data analytics, your marketing and production teams might be running some analysis on the usage. They would also see a huge spike in data. Let them know, look, this is not your real user, this is production performance test. And then after data, cost benefit analysis. Was it worthwhile doing all of this? Do a cost benefit analysis to see whether this can be repeated again. Moving on to the next slide. Now you're done. Now to the engineers who are doing the production performance testing. My tip to you guys is, production is not a test environment. It's not your playground. Okay. This is a live environment. Okay. Don't come and experiment here. Don't run any testing in production. I'll just put this small load and see. Podi load එකක් දාලා බලන්නම්, nothing like that. No, don't do that. This is a live environment. You need approvals. Okay, this is not your playground. You go and test in whatever you want in a lower environment, not in production. If you have any issues or if you need help, remember to reach out and ask help, and be very enjoy what you do, what you're doing. Tell your friends, this is like, rocket science. This is really great. Like Elon Musk's, like sending rockets to space. This is something that we do. Enjoy the work you do. One thing I have as a pro tip for all the engineers, you all might not like it, but have a checklist. When you have a checklist, it will greatly help you on what you're doing. Let's move on. How can managers help the engineers? managers who are out there testing in production means you don't skip any other testing. So tell everyone no any other testing that happens to have in the low environments that needs to go as planned. You don't do skip those. Make sure that you have the best team. Keep calm when issues happen. Issues will happen. Don't react. Remember, you can go and give your feedback later. Keep calm. Motivate your team and back your team. They need you. They need your support because there'll be a lot of pressure on the team. Continuous training, CT is a term that I came. Keep your team continuously trained. Make sure that your team is always learning. And sometimes things can go wrong with you and with your team. So be truthful about that when you're reporting. And finally, pro tip for all the managers, appreciate your team's effort, award and reward them. They deserve it. What's the future in production performance testing? So the buzzword ChatGPT, Bard, Bing, AI coming in, machine learning. Who knows? Production performance testing might be done by AI. Inputs might be taken by AI. Machine learning might be coming. But what I think is this production performance testing lifecycle, whatever comes in, this is like the basic. This will be something that will continue. And if you are going to do production performance testing, this would come in handy. Okay, final thoughts. Baba, are we ready with the voting option?
Yes. Everybody, you can scan this QR code, or you can just go to the link that I've added on the chat here, and you can vote there starting now.
Yeah, so the question to everyone is, what is Rifki's personal thoughts on production performance testing? Will I recommend it? Yes or no? You can start voting. We'll give 1 minute, quick 1 minute. I'm sure voting won't take so long, yes or no. And the pro tip is you need to read my mind. Was the link shared?
Yes, Rifki, we have answers coming in. Let's give it a minute so that everybody can.
In the interest of time, Paba, we'll take the answer and I'll give my feedback at
Okay.
the end. Let's
Okay.
have Nilanka and Omant go into the session, and I'll take the give the answer during the Q&A.
Okay, awesome. Sure.
Okay. Nilanka and Omant, over to you for the next interesting topic in the session.
Thanks, Rifki. Thanks for your valuable insight and best practices. So now we are moving into the next topic. So I have Omanta with me. So we are going to discuss about how Observe will help us to improve efficiency and performance in our infrastructure and application. So with that, we are moving into the first slide. Uh, what is observability? So we'll take an example. We'll say if your car breaks down. So then what mechanic do? So he pop up the hood and take a look into the engine and all these areas to identify the issue. So we'll say the same scenario. If your application is misbehaved or failure in your infrastructure, how you can track or troubleshoot these issues. So then the word called observability or the concept called observability coming into picture. So what is observability? It refers to the ability to understand and gain insight into the internal state of a system based on its external outputs and behaviors. With this observability, we can ask multiple questions. So it's come up with multiple questions. Okay, what is happening inside the system? Why it is happening? Or how can we improve system performance? Are there any anomalies or issues that need to attend? How can we prevent future problems? So these are kind of questions we can come up with observability. So within next few slides, we are trying to give you kind of a more overview about this one. So with that, we are moving into the next slide. So this is mainly, when you heard anywhere in this observability discussion, so you can three external measurements. So those are we call as the pillars in observability. It's come up with metrics, traces, and logs. So when it comes to metrics, I mean, it is something like, okay, what it is happening, mainly the quantitative measurements coming into picture. And then traces, it is why it is happening. So mainly the the detail level investigation. So we are using tracing, and then the logs are kind of the significant the role. It plays significant role to understand and diagnose the issue and the behaviors. So with these are the three main pillars that we are discussing, and I'm handing over to Omanta to discuss these three pillars detailed. Omanta, over to you.
Thank you, Dylan. Let's take three pillars of. So starting from matrix, matrix is a key component. So when it's come to performance and observability, it provides valuable insight into the functional and characteristics of an application, system, or infrastructure. When it's come to infrastructure matrix, there we can check the how the infrastructure behave during the performance testing or when the any application is running. So you can drill down CPU, how the CPU is, CPU, memory, disk performance, as well as network performance during the testing. When it comes to application, so application matrix, you can see total request and if there are any errors and if there are any latency, as well as you will be able to drill down when it comes to microservices, you will have different endpoints. So as let's say if you have a GET request, then you will be able to see how many hits and average latency and total time for particular request, likewise. And when it's come to custom matrix, so this is very important. So let's say in the observable platform doesn't have any inbuilt matrix. So the custom matrix will help us to create something uniquely filter for any maybe from some service, and we can group into a different level. So into resource level. So in that case, the custom matrix will help us to create some unique unlicensed data. So not only that, the observability platform support custom integration. As example, let's say if you want to monitor some database query level data within the observability platform, in that case, you will platform will provide API or SDK that you can inject particular data into the observability platform for analysis. So moving into the next slide. So tracers. Tracers actually play a major role where you will send the application level data. So how we are going to instrument and how we are going to collect the data and how we are going to analyze and visualize. So there are actually in the world there are open telemetry, which is funded by CNCF, Cloud Native Computing Foundation. So for using that open telemetry library, you will be able to send tracing data to any backend. Example, if you are using Prometheus as a observable platform, you will be able to send the traces to that particular backend. And so here in the down, you can see the data DD trace library, which is proprietary by Datadog. So if you are using DD trace, you will be able to send all the data to Datadog backend, and you will be able to analyze and visualize your data. So when it's come to distributed trace, there are two key main component, the trace ID, span ID, which keeps your service call identification throughout your request journey. So trace ID will be the main uniquely identifier for particular service call, and span ID will be change based on the call and where the microservices. There can be multiple microservices calling from the particular request. Moving into the next slide for. Yeah. So when it comes to traces, there are span is playing a key concept. So parent span and child span. Parent span is will be deferred to the main request call. As example, coffee shop web application. So the main request go to the coffee shop. Then from the main application, there will be a third-party request go to underlying microservices to get data from database maybe, or from the another third-party application. So in the first, on the top graph, you will be able to see flame graph. So here we will be able to visualize how the transaction flow through the from the request that came from the end user. So in the service section, you will be able to see how many microservices that was called during the particular request. So first call was for the coffee shop house. It will be a front end, and it's called to again PHP backend. And likewise, you can see there are many services that was called during the throughout the journey. So, and also you will be able to detect code errors. So here you can see some errors that was triggered during the uh, particular request call. And also you will be able to visualize more granular level into the infrastructure matrix, which you can identify is there are any memory issue, or is there are any high CPU load, or is there any network latency. As well as you will be able to see what are the processes run during that particular performance testing or the request time. And not only that, you will be able to drill down more into the code spot level. For the checking code hotspot, you will have to do the instrumentation for the GitHub. So if you are integrated the traces with GitHub, you will be able to get more insight and identify actively is there are any code errors. Moving into the next slide. So, okay, the logging involved capturing and storing log data generated by application services and infrastructure component. So there are actually few main areas how we are going to manage log, and how we are going to retain, and how we are going to analyze, visualize, monitoring, and alerting. So the log management is not limited to any sources. So most of the platforms supported, you will be able to send log from servers, database, or serverless application, or web browsers, or containers. So any sources you will be able to send data to observable platform. So here you can see there are few features supported. You can drill down your logs using live trail, and you can generate the metric out of your logs, which will help you to keep uh, the data more longer period, and you can detect anomalies, and you can analyze anomaly level uh, issues. And okay, let's move into the next slide. Yeah. When it's come to log events, I will more discuss about how you are going to manage your log. So the pipeline and processes. This will help us to properly format and manage when the logs are flowing, it will help us to properly format uh, our logs through the observable platform. As example, let's say if your application doesn't support JSON formatted logs. In that case, pipeline and processes will help us to convert that raw data into a JSON format and visualize in proper manner in observable platform. And custom matrix also, as I mentioned earlier, it will help us to keep data uh, more longer period, and we can create a more anomaly level analysis as well as forecasting level analysis based on the data that we are keeping. So log retention and archive. Log retention will help us to manage how we are going to store data in our observability platform. So as example, let's say you have a production environment, that data you would like to keep only for a 30 days. In that case, you can use the feature log retention and create a filter. The logs will be keep only 30 days. For the non-production, you can create another filter that will keep a lesser period. As example, let's say 15 days. So log retention feature that you can use for uh, differentiate logs and how you are going to keep it. An archive feature will help us to uh, archive the logs after keeping data in the observable platform. Let's say if any application needs teams need more than 100 days data, but you can archive the log after 30 days. Then it can forward it into any other sources. As example, RCC log server or cloud storage, maybe S3 bucket or Google storage. You will be able to forward that, and it will be not going to keep in the observability platform, but it will be forwarded to a third party storage. So then it will, let's say if any teams want to uh, check the 100 days old data, then you have a feature rehydration. So by using rehydration feature, you will be able to rehydrate data from archive bucket back to the observability platform for any future analysis if required. Also generate matrix. So as discussed earlier, this feature will help when we create anomaly detection or forecasting level uh, analysis. Let's move into the next slide. Yeah. So next is how we are going to analyze, visualize, and monitoring and alerting platform. So in the observability platform, here you can see you will be able to filter the way you want. Basically, you can filter service. I have filtered the web store service and only the errors that was written from this particular service. And the facet section, you have more granular level filters, how you are going to filter and forecast your data. And also when it comes to the pattern, so log pattern. So by identifying log pattern, it will help uh, organization to identify if there are any unwanted logs are reporting to the observability platform. Because if we keep unwanted logs, so unformatted log, that will not helpful to do any analysis, or it will increase the cost. Therefore, the log pattern identification will uh, help on that case. And in the right side, you can see there are more options with the log analysis and visualization. You will be able to drill down to pie chart. So this will help. Let's say if you want to identify any services that are sending high volume of log, then using pie chart you will be able to easily drill down what is the service or status level. Let's say if you want to drill down info level, status level, debug level, so that will by visualizing into pie chart, it will help you to identify those. And also there are few other options like table, top list. If you analyze the data into a table, it will help you to, there are features where you can export to Excel sheet and do more granular level analysis there. Okay, let's move into the next slide. All right. In observability, there are challenges and best practices. So when it's come to challenges, based on the infrastructure complexity. So infrastructure complexity means organization can have multiple infrastructure environment. It can be on premises, it can be a multi-cloud as well, AWS, Azure, and GCP. And also it is important to, it is a challenge, how we are going to measure how much data volume will be going to send to the observable fact, and how will that impact will that impact to the speed likewise. And also it is a challenge when you are working with multiple teams within the organization. And also it is a challenge to identify what are the key metrics that we are going to monitor, analyze within the observability platform. Okay, when it's come to best practices, so defining clear goals, which is the most important. So that will help. Actually, we have to plan prior. What is our goal? We are what what is our, we are going to monitor through the platform, and how we are going to instrument. Correlation and context will help you to granularly identify if there are any errors within the traces. So if you correlate traces and log, so that is a best strategy. You will be able to identify properly any issues within the application. And it is important to focus about the automation and anomaly detection part. And also team collaboration also very important, because in an organization there can be many teams and many applications. Therefore, collaborating with among the team, it will help you to develop a best observability platform. And also it is important collect how we are going to store and how we are going to visualize. And also after you storing everything, so it is important to create a monitoring and alerting mechanism. So create important monitors and alerting part. So when it's come to alerting, you will be able to alert them into a email or Slack channel or Teams or else ServiceNow alerting platform, based on the organization platform that you are using. And it is important to keep continuous improvement once you have built the observable platform. Yeah, those are main for the challenges and best practices. Hand over to Nilanka.
Thank you, Omar. So we have covered main key pillars when it's come to observability, and then we discuss about okay, what are the challenges and best practices. So next we are moving into the advantages. So we have listed down few advantages. I mean there are more, but we have listed down few. So performance bottleneck identification. So this is kind of one of the best one that we can help observability to understand the bottlenecks of our application. So there are some key metrics we can use when it comes to the response time, latency, or resource utilization. So these areas will help us to understand where's the bottleneck in our application, and then immediately we can take necessary actions to improve that area. And then the capacity planning and scaling is another a key advantage that we can highlight when it comes to the observability utilization. So, for example, we'll say if we have a proper mechanism of if observability tool will send us the metrics or the data related to the performance. So then we can understand, okay, where we need to scale up or scale down our application, the features. For example, if one application is utilizing more memory, so then we will be able to decide, okay, whether we need to enhance our memory to cater the requirement. So like that, with the support of the observability data, we will be able to go for a capacity planning and the scaling. And then the troubleshooting efficiency. So that is kind of a key area because we have more data now. So we have traces, logs, we can go deeper into the troubleshooting levels, and we can identify, okay, where we need to troubleshoot, and immediately we can take necessary actions to troubleshoot. And that help us to improve our MTTR, because that is the end goal before it's impacting to the users, how soon we can provide our troubleshooting and do the final resolution. So then the continuous performance optimization, this is very important area when it comes to the observability, that based on the key metrics, we will be able to identify, okay, how we can improve our performance and where we need to focus to performance improvement. And then the real-time monitoring and the alerting, that is kind of another advantage, because as Omanta said, okay, we can trigger expectors or any other the emails or the Teams message when it comes to the alerting. So that will help us to immediately attending on to the issues and take necessary actions to avoid user interaction. So those are kind of key advantages that we have highlighted when it comes to observability tools. So I'm moving into the next slide. So that is mainly we are trying to give you kind of understanding or the background about what are the available tools in the market. So these are not only the tools, there are multiple, but we have segregated into two areas. One is the enterprise solution level. So these are kind of a paid tools, Datadog, New Relic. So these are key tools, and I can highlight a few benefits. Those are accessibility is very high, and then the security level is very high, and then the less maintenance. So this we can use as an enterprise level. But when it comes to the open source, we have some tools. So these are we can use with the minimum cost, and then the startup level we will be able to use these tools, and then the flexibility for developing the features are high in here. So we can use the open source to develop our own features when it comes to the open source solutions. So these are the key tools that we are having in the market. Not only this, but these are some tools that we can highlight in this observability usage. So with this, I'm trying to I'm going to conclude the session from my side. So mainly we learned, okay, how observability help us to improve our performance in our application. So what are the key pillars, and then what are the benefits, and what are the challenges that we have. So all with this, I'm going to conclude. Thank you very much. Over to you, Papa.
All right, team. Thank you so much for a great set of presentations. I think the audience really appreciated it. And while we are on that, before we move on to the question, to ask questions, we've got a couple coming in. I've just shared the link on the chat as well. So just keep the questions coming. In the interest of time, I'm going to get to the questions right now. All right, let's see what the questions are. So I will direct the first question to Rifki. Rifki, your question is, do we need to clear the junk data that was created from production perf test, or isolate those from the actual users?
Okay, thanks. If I understood the question, so if your junk data, first of all, your data should be isolated from your actual users. So whether it's junk or not, if your data is not isolated, you have a bigger problem there, right? So make sure, first of all, your data is isolated from the actual users. Second, if it's junk data, you need to determine how long you can keep it there. Can you keep it there for 1 month, or maybe about 2 or 3 months? If it's isolated, it has to be isolated. Then you figure out how long you can keep it, and then you need to work out a timeline to clear the data. I hope I answered that.
Yes, thank you so much, Rifki. I'm going to direct another question at you, but do you want to go through the polls right now, or do you want to come to that later?
I'll go for that at the end.
Okay, cool. So one more question to you, Rifki. Cybersecurity policies usually blocking production of performance testing. But how can you make sure that there's no security breaches open through the production test?
Yeah, honestly, I don't know if this is a correct answer, but what I feel is the answer to that is maybe you can have your load generators within the the configure, maybe firewall or on premises the load generators. You can have it inside so that it does not alert the it does not breach the security policies, or you could have a dedicated IP that the load is generated, and then your security team or your tools know that the data coming from this IP can be excluded. It is a security breach, but if you can do that during a limited time and with confidentiality, that will be good. Maybe, I'm not sure, but I think it should be possible if your header has certain values, and if those tools know that if something comes with this header during this time, this can be ignored. Maybe those are some things that you can do. So I hope for the person who asked that question, that is the correct answer, but that's the answer that I have.
Awesome. Thanks, Rifki. We are directing the questions to Nilanka and Omanta. We have a question on observability platforms. And that is, can observability platforms support tracing when multiple systems work together? If so, how are they going to trace the message flow among systems?
Yes, ma'am. So for that, actually, it is possible. So you will be able to build down the dependency servers. There is a dependency map where you will be able to see the underlying subsystem request, how it was flows.
All right. Thank you, Omanta, for the answer. We have one last question. If the audience has more questions, we are open to take them. The last question, Rifki, is directed at you. Doing production testing, is it really worth considering the cost? What are your thoughts based on perf tests, based on past tests that you have done? You have to unmute, Rifki.
If you ask Netflix, is it worth doing production performance testing? Are they worried about cost? They'll say no, because the amount of revenue that they generate and the cost that goes into production performance testing is negligible. And it sometimes is not about cost, it's about reputation. You might not have a direct cost that you will be incurring because of production issue, but the reputation that you have with social media impact, where people will just post something on FB or even Instagram or whatever saying this particular system is down, that reputation cost is sometimes not measurable. So then you need to figure out whether it's worth the risk. Then again, if you are having a small system, maybe a library system in your home town or somewhere or something, a small a doctor in a clinic in a certain area is having something like that, there are no major people coming in. I'm just saying a very low end performance load thing. Those type of systems don't need production performance testing. So you need to weigh in, and like I told you, cost benefit analysis to see whether it's worth taking that risk. So yeah, I'd leave it at that. I hope that person, whoever asked, gets the answer.
Awesome. Rifki, we have come to the end of the questions. You can share your poll results out. However you want to take it on.
The poll results, you have it, right?
Yes, do you want me to share it?
Yeah. Let's see what
Of
the
course.
results are.
All right. This is how it looks like. I hope you can see my screen. Not yet. Okay, what about now?
Yeah, so, okay, 69%. 69% say yes, and 31% say no. My answer goes with no, and I'll tell you all why. I'll take my first example with the doctor. So you go to the doctor and say, doctor, I have a heart problem. What can I do? The doctor will not tell you do the surgery. He will first tell you to do some exercises. He will first tell you to cut down on all those junk food, fast food. Then he'll give you some tablets and so on. And then if nothing works, surgery is the last option. Okay, so production performance testing is not your first option. There are other shift left performance testing that you need to do that will help solve and find out the issues that is needed. So it's I would say a no. Don't take production performance testing as your first option. There are other tests that you need to do to find performance issues. But if production performance testing is needed, like I said, if surgery is needed, there are best practices to be followed. And I hope what I shared will help you to do the production performance test. That's my answer. Thank you.
Awesome. And with that, folks, we've come to the end of PerfUp 6. A huge shout out and a big thank you to our three speakers here, Nilanka, Omantha, and Rifki. Thank you for spending so much time on this over the past few weeks to get this together and get all of these insights out and share this with the audience today. And team, I want to remind everybody to join us at PerfUp 7. We will be announcing what we're going to be talking about really soon, and hope to see every one of you there. And don't worry about the recordings. We've got a couple of questions about the recordings being shared. We will share this recording to you as well. If you don't have any luck, you can always refer to the Sysco Lab social media group. Social media platforms where we'll be posting the link for the recording, and keep in touch with us on our meetup group too, where we will be constantly updating the discussion forum. And thank you, everybody. Have a great rest of the night. See you soon.
Thanks, everyone. Thanks, Sysco team, and thanks everyone who helped. Thanks, and thank you, Nilanka and Omantha.
Thanks, Rob. Cheers.
Thank you, everyone.